All right. Let's just do this thing. Oh shoot! I'll have to get the vacuum. Wait, what's going on? Am I live or not? It seems like I am live, but then now it's giving me some crap. No, I'm good. I don't know what the heck it's complaining about. Alright, so yeah, we just gotta get rid of all this crud. I should have tried this with no supports. Okay. Wait, no, but I actually don't want this. I'd rather have the other one. Okay. Oh no. Nice. Should be good. Alright, so we're almost done. We just need to get like an Allen key. Or actually, you know what? I need like something hooked. The freaking slot for the nut. This is why, okay, so this is the thing, is like, I didn't even think about this, but the manufacturing of this, like, the counter bore is would have been way better. How am I going to get this thing out of here? Yeah, I think I got it all. Yeah, it feels good. Okay, one support thing removed. This one should be easy. Oh, we have one more of these slots to get. Yeah, okay, wait, alright. Okay, so what I think I want to do first is just Alright, well, let's try to... Okay, that's pretty good. Oh, wow. I just bent my Allen key. Fuck. See, that's the problem. This stupid slot. It's brutal. If I had to do it again, I probably wouldn't do the slot. Or at least I would make sure to do it without supports. Gosh, yeah, that is the worst. You know what I think I would do? I think instead of counterboring it from the bottom, I would counterbore it from the bottom of the rail. I think that's way better. I'm not going to reprint it because this is probably going to work, but for manufacturing, for printability, that was just awful. I gotta go get the little vacuum. Alright, I think I got most of it. Okay, finally. Let's see, is my chat even working? Okay, alright. Let's get to work. Okay, so we're gonna need to put that away. So first off, let's just take this out of here. This is junk. So this, honestly, I feel like I am gonna redesign the part. Let's see if this is gonna work though. Do a little test run. Okay, now let's just make sure that oh wait, it shouldn't, it needs to be. Oh, okay, great, it works. Even though it's garbage feature in terms of everything else, it works. Okay, great. So we put it, okay. Okay. I'm so overwhelmed right now. Okay, let's just do this. So this needs to be on this side. Alright, this part's fine. So we can just install that, but before we do that, I should have thought about I don't know why I thought about the counterbore from the bottom instead of just counterbore from under the rail, because that's way smarter. Is it? I feel like it's better. Okay, so those are the 35s, so we need to get this out. This is actually something we need. So we need to stay clean. Keep your station clear. Messy apron, clean sleeve. Okay, so we no longer need 35s. I think we want 20s, right? And 3 by 20, which one is that? The third from the, okay. Alright, so let's see if this is going to work. I could probably do 25 too, but. Wait, what? Wait, this counterbore is not. Wait, what? Alright, I might just have to heat set this and change it in CAD. Damn. So these are manufactured slightly differently than the ones that I had. Okay, well, no matter. I think we can solve this. But also, wait, let's see if I can just shove it in with a 25. If we can grip it with the 25, maybe it will work. Because 25, I think, still has the clearance for it. Let's see. Okay, so we need to... Alright, so let me add that to the to-do list. This is not pulling through. Okay, so let's just use... We can just use 25s. But that's definitely an error. Okay, but it's not going anywhere, which is nice. Okay, so we need an M3 nut. Oh, wait, this is the wrong one. We need to take this out. Okay, I'll just push it out. Okay, so wait, what was this? This was also, okay, yeah, it's kind of unfortunate. Now let's do a test. Cool, alright. So I think first we want to install this guy. So these are going to use, what did we say, 25s or 30s? I need to put this in the freaking CAD, bro. Let me just pull up CAD really quickly. Why is it, what? Why is it being so weird? That's not even the right face. Why is it even... Alright, let's just get this. Why is it being weird? 26? So we need a 30. We can't use a 25 there. And I believe that this is going to be the same thing as before, where my counterbore diameters were... Actually, these counterbore diameters look good, though. How did I mess this up so badly? Why is it showing me, like, literally every sketch? They're all hidden, but it's showing me every sketch. Okay, that's better. I don't know why I was doing that. What? 5.4? 5? Weird as heck. Alright, so these counterbores are good. Let's just install it. Alright, so let's just switch back then. Now we did our little... Okay, wait, hold on. I need to fix the counterbore. Let me Let me just add to-dos to some sort of README somewhere. Just put it in the README. Okay, so I need to, instead of slotted nut, put a counterbore under rail. Makes, because the support removal for slot is a nightmare. Also, for the counterbore on the rail, counterbore on the bolt that goes through rail, need to increase diam. Okay. All right. So, this is a 20. We don't need this. Okay, and this is 30s. We don't need this. Okay, then what is the width of that wall? That's 8.4, so we should be able to use a 10 or a 12. I guess we want 4. We want a 12. I'm pretty sure I can find some 12s in here. Do you guys hear that? It's just going to be that all day. It's one of those days, man. Kind of got a headache. It's just one of those days where it's going to be annoying as hell. Oh, well. Oh, and we didn't counterbore this. I don't know why I never counterbore anything, but it's like, you really ought to. I don't think it will have an impact, but... Well, okay, let's install some 12s. And we will see. Ugh, these bolts are, even though I made this window, these bolts are still impossible to install. Maybe if I had one of those, no, I still am not gonna, maybe, because if I had a straight one, ugh, God. All right, I give up on these. Two is enough. Okay, so now we get the rail in. And now we're using a 25. I believe these are 25s. It's not. But the threads are somewhat engaged. But but it's moving in there or something? Still moving in there? Nice. Perfect. All right, come on, let's just power through this thing. I'm so sick of not having this thing working. It's bumming me out. So should we rig the... We should probably rig it right now, right? So I forget... I guess I need a new belt, right? So let's figure this out. We need to go from like... Oh god, okay. I need to go on a walk and see what they're doing and try to estimate how freaking long this is going to take, because it's so loud. It's so freaking annoying. The quiet neighborhood, guys. I just want to go live in the forest. Quiet neighborhood. No machine tools all day. Or if they're machine tools, they're me. And it's only me. I'm so sick of this construction. Okay, but so the plan is we're going to rig it. Then we're going to install the Y-axis. And why are those so poorly done? Wait, what? In the CAD, is it like that? The pulley wheel is at the bottom. Okay, frick. Let's just do it. So, we need some clippers. Oh wait, this is the wrong thing. So we need this to go like this. Okay. That's pretty generous. Well, because you have to add for the diameter. Okay, now we want to go to there. Alright, so I'm just going to cut it. This thing was really cheap, so it's like not a big deal. Alright, so the way to rig this thing up is Let's see, how do I rig it? I forget how it was. Let me think about this. I'm pretty sure I need to go from under. So I go under. Is it under or over? Oh, that's plenty. That's plenty of belts. Okay, so you fold it in half and then you just press it in. Okay, now this is at its longest. Wait, but what we want is we want it to be like... Wait, hold on. God, give me a minute. let's just do this thing, man. Okay, so what we want is at the shortest. No, we kind of want it to be in the middle. So I'm going to tighten it down at the middle. Actually, here, I'll go short, and then we'll make it a little bit loose. Okay, so now it's kind of loose. But then what I can do is okay, now all I have to do is I gotta get a vise on it. Wait, but it loosened. See, this is the problem, is I knew that this thing was going to be, like, brutal. It's just so hard to get in there. I'm wondering if I can maybe go this way. No, but you can't get a full turn. That's why I should have made this thing longer. I should have just made it wide, like, because we don't really have a constraint on that. I knew this was going to be an issue. how do we get this thing tight? Alright, if I loosen this. It's just too loose. Alright, so it's going to be loose like this. I just want to see if I can get tension on it at all. Because it feels like I just don't have the mechanical advantage I need. So, okay, so here's my strategy. So it's loose and can be moved. But I believe if I get this just right, you know what I need? I need like a, let's see, it's like a hex wrench. What do you call it? Like a hex wrench? Because actually that would work. What I would do is I would it's just so loose. Why is it so loose? They made this look so easy, this slotted business. Or I think what I'm actually gonna do is just do it like we had it before. We want it to be like. Come on, go in. I think I broke it. That's the problem. It needs to be stronger. Okay, I was able to get it, but it's... What you really need is like a smarter mechanism. Okay, so the problem also is that pin... Well, let's see if we can do it. Let's just see if we can do it. Oh, nope, I broke it off. I mean, that was a weak part. Damn, dude, I really thought today was going to be the last day I had to freaking do this. Oh, I'm so sick of this project, bro. Yo, no, dude, it's not. And everything is broken about this thing. It's such a crappy design. I wonder if I just put this in here, will it slide out without anything holding it? Actually, that holds pretty well. Maybe we can hack it together. I mean, okay, so wait, hold on. I have to fix more stuff. So then so there's the slotted nut is trash. The counter bore needs a bigger diameter. What was it? The counter bore on the bottom nuts for the counter bore on the bottom nuts for the X-axis motor, and currently they are super inaccessible. Honestly, it would be better if we just... It would be better if we just made that a wall and have them go totally across. Let's see, under tension. See, if we're under tension, we definitely have clearance, which is good. I mean, this thing was designed pretty good. It's just like, it's so bad. It's just so fucking bad. Okay, I want to Google belt tensioners. Okay, wait, so we need to... So the slot for belt tensioning is UX, user experience nightmare. terrible mechanism. Oh gosh, it's so bad. There has to be a way to use like what I'm imagining is like some sort of way where you can get mechanical advantage where you don't feel like you need 3 hands. Because what you need to do is this is how this thing works, which is so crazy. So you basically need to put pressure on here pushing backwards while it's loose. Then somehow, while it's under tension, get that nut tightened, which is like, I don't know how to do that. So I am going to try to get it working because it does seem like it's possible. But it's like, dang, man, this is the worst. So hold on. So there's that, and then there's another thing. We need to fix on the x-axis belt. Well, I guess it's on the other ones too. I think what I want to do. So the slots for belt holder is the pegs for belt holder are too weak and can easily break. So we need to redesign that geometry too. It's so funny how it's like, oh my gosh, there's just issue after issue. I need to go get a sandwich. I need to go get a. Jeez. Today's not my day, bro. Okay, so wait, hold on. So let me just see if because I think we can still get it working, but it's like. I don't know. It's going to be really hard to get tension on this belt. That might be somewhat usable, but there's still so much play. Like, I would prefer... Okay, wait. Let me just Google... Is it possible to make it work to... Well, the thing is, I want it... I mean, okay, here's the thing. The videos that I make, I don't want to... Like, I want to show the reality of, like, if you want to build something good, it takes way longer than you think. Because stuff just keeps going wrong. Wow, look how much extra belt. I always waste the belt. I should probably buy another belt, just in case. But no... Wait, hold on. Let me get a sense of... Why does it feel so hard to pull? Why is this thing so hard to pull? I think it's because this is too tight. Oh, you have been? So I've been using CapCut. But I've been meaning to check out DaVinci Resolve. Oh, there we go. See, that's better. That's kind of the tension that I'm thinking of. But it's so loose, bro. See, that's the problem. This slotted design is not very good. Because the problem is what you're doing is you're compressing the plastic enough to make it... Oh, this is definitely the low point of this project, man. CapCut's made by ByteDance, I think. It's made by the TikTok company. It's pretty good. I've never done anything serious with it. Okay, let me look up belt tensioning mechanisms. Oh, that's actually interesting. But that's still okay. Yeah, so you have a, okay. Wait, hold on. Wait, why did that show me? Why did that just give me what? The wrong image. I'm trying to figure out what the best course of action here is because it's not clear what I need to do. Because this is not going to pull. This is definitely going to skip steps. It needs to bounce. I gotta get some food. I got like a headache right now. I gotta take a minute because okay, I think my understanding of why this thing is not working is when you tighten, you don't want that much play, but you want it's kind of an interesting trade-off, right? Because so the pulley wheel maybe has like 0.2 millimeters of clearance inside the slot, which is really not that much. So when you tighten down the bolt, you compress the plastic enough so that there's a high friction force pulling the pulley in, or pressing against the sides of the pulley wheel, so that basically it can't turn. So that's one reason why this doesn't work. But the other reason is that it's just a terrible mechanism. It's just terrible. Nah, yeah, you're good. You're good. You could just do whatever you got to do. Belt tensioning. Belt tensioner. Yeah, it's an interesting idea. To tension a belt by... You have a... Oh, that's really cool. Yeah, so you have a second idler. Honestly, I don't feel like I need that, though. What I feel like I want is... Let's see, what is the mechanism? I need some way to have like a worm drive or some sort of lead screw that allows me to, with high mechanical advantage, adjust the tension in the belt without having it spring back, without having it back drive or whatever. There's got to be ways that people do this. Let me just ask ChatGPT. So I upgraded my drawing robot, and I wanted to have a way to adjust the tension on the x-axis belt. So I added a slot, where that for the bolt that goes through the idler pulley wheel. And the problem is, this mechanism is like kind of crap because while the slot does work and you can pull it to the correct tension, it's really hard to tighten it down once you get it to the right tension, because you kind of need 3 hands to do it almost. What's an alternative mechanism where I could better adjust it, kind of like add a small threaded rod or screw mechanism to your idler pulley mount. Okay, wait. Let me think about this. So let's say you have like a mount here. So there's just a beam. It's just going to be a metal rod. It literally, I guess it needs to be threaded at the end, kind of, but like it goes through the pulley. Well, okay, let's just imagine it as a bolt and a nut. The nut will have the trick is going to be getting, so a bolt goes through a nut perpendicular to the axis of the, or I guess parallel to the axis of the belt. Then as you tighten that screw, it's going to push on the tension of the thing, and it should not kick back. The only problem is, however you do this, I guess what I would have is, I kind of want to do this. I kind of like that idea. So you basically, what you do is you have a big piece of plastic, and I'd probably use a thicker nut if I could. Well, I don't know if I can. And I don't know if I have a longer, maybe I do have a longer thing, because you don't have that much room, though. It's a good idea, though. Yeah, so its example is use a nut trapped in a pocket. Or a threaded insert on the idler mount. Oh, actually, we could do it in the walls, right? We could do it in the walls. That's kind of a good idea. If we make the walls thicker, if we make the walls thicker, we need to make sure we have the correct bolt size, because I think M5 by 30 is the most that I have. And this might be 30. A spring is also kind of a nice design, but I don't know how I would do a spring mechanism. Okay, so let's see, what's the distance there? I think it's actually, we need to figure out how much more distance we can get on this thing. So if we go to the idler, the distance between here and here is 25. So that's not great, because then if we have a 30, then we only get 5 sticking out here. And the thing is, I'm really opposed to specialty parts, because I'm pretty sure that I'm really opposed to specialty parts. I don't want to buy a special part, but it's like, honestly, the old mechanism wasn't that bad. But I like want to conquer the challenge, kind of. I really want to try that mechanism. Let me go see if I have okay, if I have a 35, because we only need, let's see, we would probably need the wall thickness to be 7. And this wall thickness is probably like 5, 4. Yeah, we'd probably want it to be 7. But so let's just say it's 5, right? I really want to try this mechanism. I feel like this would be really cool. Plus, because you have a lot of threads for engagement, even though they're tapped threads, I have a feeling. I guess you could do threaded insert, but threaded inserts are so weak that you're not going to get good tension on it. I feel like the tap is the best bet. Huh. Okay, so I think I am going to attempt this, but let me go check what bolts I have. So yeah, M5 by 30 is the biggest. So what I'm wondering is we have M3 by 35. And that's the longest that I have. I don't know if I'd want to print this part. All right, we're going to try this. So here's what we're going to do. So the one kind of sketchy thing is I'm going to use an M3 by 35 in a pulley wheel that has an inner diameter of 5 millimeters. So I don't know what could go wrong there, but I'm guessing that is not really how you want to do things. I'm trying to think about, because if we have the correct amount of tension, then okay, so then this thing shifts like this. I think it shouldn't matter. I think you can use something that's not... I don't think that the play in here is going to matter as long as it's under tension. I guess we're going to find out. Actually, I have an idea. I have an idea of how to use... Because you can either apply the... You can either have the leads... The bolt hitting... You can either have the bolt hitting the actual threaded section of the bolt, or you can have it hitting the head and the nut. And I feel like there's a way for me to get both. Meaning to keep using the M5 by 30 and okay, so yeah, but I probably want to get as big of a bolt for the tensioning because we want strong threads. M3 threads, their pitch is so low, and we don't really care about having a low pitch necessarily. All right, I think it's a plan. I'm going to go get my sandwich really quickly. I left my... And then... And then we're going to CAD it. We're going to reprint this part. I'm going to make it bigger. We're going to make it way bigger. It's going to look more symmetrical. It's going to be kind of overkill big, but the I don't know if I want to make it bigger. Okay, but unfortunately, there are 4 parts out of 8 that need to be reprinted. I no longer trust this design. Let's see if you can. Am I on the right thing? No, I'm not on the right thing. Can't I just make the belt? It's yeah, you can make a parameter for it because it's not always COM4. It's not. For all intents and purposes, it will probably be COM4, but because that's my desktop, I don't know. I would make it a parameter. No, you can't make the belt shorter because the whole the whole problem is that it's super janky to. Oh wait, this was the geometry that I was talking about. Is this little thing that holds the belt? Anyways, so the problem is when you have to get this thing on here, you have to be like really clever, or you have to like and hold it real tight and get it in, and it's kind of a pain. What you want to be able to do is put it in loose or relatively loose, and then just do something that's low stress. Okay, so I think I have a plan. Dang, man, it's so funny. I'm actually I'm really happy. I got to be honest, in general, that I've run into so many issues because I feel like this is what makes an engineer is the trial by fire. Is that when everything is breaking, how do you work around it? Because like I can copy all these other people, but if I want to like solve the problem myself, I gotta like see it. Anyway, so I think all right, I'm gonna go get some food. I'll be back in probably like 20 minutes. Okay. Food acquired. Okay. So, $H, if you look up the documentation for GRBL, $H means home. Mm. Banh mi is one of the best sandwiches, bro. I love banh mi so much. See, why did I choose 3 here? Mm. What is this? Kind of tastes like fish, dude. That shouldn't be. I got a second one. I gotta fuel up, bro. I didn't really eat anything yesterday. Oh, what the hell? I want to check about this, though. See, this one seems good. I don't know. That's weird. Ideally, if you used one big nut, it could work. I don't know. I kind of like it on the outside more. But I also like it on the inside because if you put it on the outside, then you need to tighten 2 screws and you need to tap 2 holes. Whereas you only need to do 1 if it's on the inside. Okay. This is my solution to the problem. Okay. In here, these slots, what I want to do is have a way on this face. I don't know. Oh, it's doing this thing again. Hold on. Okay, there we go. So I want to widen these walls. Oh yeah, I forgot. Oh yeah, I forgot. That's the other downside. Oh wait, no. I'm not widening these walls. What I'm doing is I'm just adding a section, a big block from here to here. And I'm going to do that on both sides. Then I can tap that hole. And then I put 2 big bolts in there. And I can tighten those. And that will tension the belt by shifting the pulley wheel back in the slot. The other option is I instead add a rectangle like here that's like 10 millimeters. And then we just have it the hole either off center, probably off center because the pulley wheel is not symmetrical. And we would do it on the larger diameter part. And then we would only have to tighten one screw. I don't know which is better. Let's see. Okay. I don't really care about this one. No, there it is. What the hell? There's like clearly like marinated fish in here. Okay, so let's just get to work, I think. So, let's see if this works. Okay. Alright, so let's just get down to it. Alright, so we're just gonna cross them off the list, right? Unfortunately, we have to do like, so we're gonna go like this, is it that? We're just gonna delete this. Perfect. Or wait, can we just disable them too? I wish I could make them like a group, you know? Oh, you can't. This is gonna be that slot. And then I wanna just suppress. Okay, so what we're gonna do instead is we're gonna sketch on here a polygon. And I don't know how we want to do it. We want to do it like this. What does this number represent? It represents the width across corners. So we want this to be the whack. M3 nut whack. Can I get out my calipers? I thought we had... Where the hell did... Wait, am I on the right scene? Okay. Oh, here it is. But we want to add like 0.3 or something. Okay. Okay. And this is going to be how much? It's going to be... Nut. Wait, M3 nut depth. So we got to go here. We got to go to params. Is it 2.4? Let's check it again. Let's do 2.5. Okay. So, great. So then we have... I don't like that. Okay. So then we got to go this. Like that. Then we got to go here. Open a new tab. We got to go here. This shit is just so slow. Oh my God. Okay. So that's what it's going to be now. So now we got to do that to the other one. So we want to go... Oh wait, and we got to be careful because whenever we do this, you got to make sure that you do this. Okay, so we're going to go... I believe that's it, right? So there's going to be... So add selection to folder. So there's going to be... Okay, and then if we suppress this, all right, that's all good. Then what we want to do is we want to roll back here. It's so annoying that you have to duplicate. Oh, wait. It's B. Okay. B for parallel, obviously. Okay. All right, so let's just say, so this is the to-do. This is done. Okay. The counterbore on the bolts. Oh, yeah. Yeah, so what it was up with that? What? Socket head diameter. Oh. Yeah, so what we need to do is wait, M3 socket diameter. Wait, what? What? I think it's because I have two different sets. These ones actually have a bigger head than the other one. So then where's that other guy? M3 socket. So wait. So where is this parameter? Where is this coming from? M3 socket head. It must be from. But this is the correct one. So wait, let's just change this. Okay, so this is what we're doing. M3 socket head hole. Oh, crap. Okay, but now we gotta do it on here, right? Okay, so we did this. Kind of on the bottom nuts. We don't really need that, but what we do want. I wonder if I can just do this. That should make it slightly better. I still think it's going to be a pain in the butt just because it's so low. Okay. Slot. Okay, so we need to fix the pegs. So let's go to carriage. I want to make this a variable. Let's make it 6. I think it was 3. We're doubling it. Should be way stronger. I think it's going to be more annoying to install, though. But you know what? We're going to have to live with it because right now, this is just too weak of a part. There's just nothing holding that there. But if it's 6, it's significantly stronger. So the first one that we need to do is on this part. Nope, wrong. See, that's going to be a... I think that's going to be a huge pain. Because what was really nice about the install with the 3mm was that you can kind of like slot it in and you could just sort of push and it would work its way around it. I think 6 is too much. Let's just try to decrease it to 4, but that's only 1 bigger than it was before. But maybe that's the strength that it needs. It only needs to be slightly stronger. All right, we're going to try that. So let's now go fix it everywhere else. Navigation is so slow in this crummy. I think this is old. I wish it would also, like, when you make a version, it would at least tell you what parts changed in geometry. But it doesn't even do that. And then I kind of wanted to build a fun part. I kind of had an idea for a fun part. I was thinking somehow I need to mount a GoPro to this. Or wait, no, rather to this. This goes up to there. It would be easier to mount it to here. We can do that some other time. Okay, wait. So okay, so there, but now, so we did the pegs. Went from 3 millimeters to 4 millimeters, which is not a lot. But honestly, maybe that's in terms of a ratio. In absolute, it's not that much, but in terms of a ratio, it's actually probably quite a bit stronger. Okay, what is next? Okay, so now we need to do this thing. Let me think. I really kind of want to try this. Oh, wait, how do I want to do this? See, that's what I'm saying is how do I get this so that here we go. Oh. See, why doesn't that work? Why don't I just put the number in? That's gonna lead to disaster, but what if we just put the number in? 10.8. I really don't like it, but I feel like maybe it will work. Okay, but now where do we put the hole? Which way is the thing going? I don't even have this thing put together. That's so crazy, actually. At least we have the pulley wheel over there. So then okay. Wait, so we want it on the far side. Okay, so we want it to be, okay, so, hold on. So this, okay, so then we just want it to be, and then that's 7, so we just want it to be, we're gonna do, it's gonna be, let's just say it's an M5, and it's gonna be on the left side. Wait, what? Just do the biggest one we can. All right. Okay, well we did it. That's the feature. What a joke, dude. I feel like a clown. Oh, yeah. All right, when we did this. Okay, so then there we go. Can you select multiple at once? Oh, there you can. So those are new. Oh, but see, this is not how we wanted this to go. Okay. I do feel like a clown, bro. Real designers, man. Okay, well, let's just export all of the parts. This part is so goofy, dude. Oh my gosh. All right, let's just export it. So this is going to be. Let's just put V5. That's the version of the whole thing. Okay. We're gonna try this thing, man. I hope this. I'm not gonna reprint. There's no reason to reprint the motor mount, really. This one I do need a reprint, though. And then carriage. Oh, fuck. Wait, what is this curve here? Oh, the helix. And then technically, what is left? It's just this part now. Is there anything else? It was this, 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 and this. 1, 2, 3, 4, 5. But we're going to print 4. We might as well print all 4. And you know what? Actually, wait, that's not going to work. Unless we counterbore that. No, but that's not going to work. Because it's going to stick out a bunch. Oh, okay. Well, at least I noticed that early on. Okay, so the problem is this design This thing is going to come in here. I'm pretty against losing travel because of things like this. All right, so that means that we have another option. So we need to go back, undo that. Okay. Okay. So we're going to have to go in and delete that. But what I'm going to do right now is we're just going to do the rest of the hardware, I think. What is that? But even still, actually, there's kind of no way around that. Shoot. Ugh. You would have to have like a... Oh my gosh. What else can we do to tension this thing? How else could we get this thing tensioned? If we move it back... Okay. Because I had the initial idea of just making this way longer. If this is way longer, then we can move this back, and then we can have this go up to behind this so that we have the travel and room for the hex head. Also, I don't think that this is going to be enough room for this hex head if it's going to fit in here. So we're going to have to rearrange that. And I'm fine having it go a little bit over the end. I think that'll be okay. Okay, I think that's what we have to do. We just have to make this thing way bigger. We have to make it closer. We have to make it more similar to this. So if we make this longer, we push this back instead of off center, but this is tangent to this line, but then this is no longer tangent to this line, then we can make some progress. But I'm not giving up travel. I refuse to give up travel. Dude, that's crazy number of lines of code. I'm surprised that it takes that much. Rust just has so much boilerplate, I guess. But it's also, we have so many nice features like logging and tracing and all that. Like that's really nice to have. But it is funny how much goes around basically sending a couple of lines of G code to my computer or my Arduino. Okay, wait, hold on. Okay, so we gotta get into the weeds here, I guess. All right, I have a plan. And then I want to change. Oh, yeah, so wait, hold on. In doing this, I want to like. Okay, where are all the uses of threaded inserts? I feel like for like. Okay, let's just do it. Let's just do it. I'm being a baby. I'm literally being a baby. Okay, so the main thing we got to do. Okay, so let's just do it one at a time. Are there threaded inserts in this part at all? No. Okay. Are there threaded inserts in this part? There's one. And I believe if we take this and hide it. Okay, so we don't see one in there. So that means that we have to go to this. Wait. Switch to. Okay, now we need to, where's the rest of everything? What? What? I'm so confused. Switch to Y. That was weird. I don't know what I did there. Okay, so then hide that. Insert other documents. This should have been renamed. Is that what I named the document? Okay, we just got to go hard for like... Nice. Okay, we got to go hard for like 1 more hour, and then I can print and I can like take a nap or something, because I'm like, see, why is it called... Wait, let's just make a version. It's called insert, threaded insert. That's pretty basic. So I don't know where it's getting this weird ass name from. There we go. Okay, so what is this one? We need to actually know what it is. Before I put it in, it's not giving me the measurement. That's 6.8, and the depth is, I feel like that's wrong also. 6. All right, so we're just gonna say it's 5, 7. ID is 5, OD is 7, height is 6, pitch is that. That's fine. Okay. Bam. All right, and that's the only threaded insert in that part, but there's 2 in here. There's 2 in here, and these are blind holes. So we're going to take this, I'm going to hide it, and what we need to do is we need to go to X, open a new browser tab. And we want to look at those threaded inserts and copy them. It's so annoying to see their config. I just do copy and paste. Great. That's so annoying that you can't do that. I don't know why you can't do that. In any case, let's just find its configuration. 2 3.24. Okay, 2 3.24. So insert 2 3.24 generate 1 2. Give me the center. Oh my god. Wait, what? Oh my gosh, why are you being so cruel to me today? There and there. Enter. I thought I had a rapid fire way to do this. Oh, that's what I need to do. I need to touch the outside thing. Boom. Okay, and then what did we put in there? In X, what are these bolts exactly? 2 by 8. Okay, great. I thought there was a better way to insert into this thing. Oh, this is gonna be a pain in the butt, dude. We need to move this. We have a lot of room. We need to move this that way. Okay, so wait, we need to figure this out. Okay, so now we got to go edit this. Oh gosh. It should be, this shouldn't affect anything else though. So this sketch, let's see, we need to make this, instead of that, we need to make this. No, but I want it to be straight. Why is it doing this to me? Let's just make it 10. Okay, if we did that, we updated this thing. Now, we go back. Great. That's all I needed. I just needed a little bit more room. Cool. No biggie. All chill. Okay. So now we need to add, okay, so now we need to actually go back to that. Because these are through holes. So that's a mirror. Okay, so what is this? So what we want this to be is, let's just make it an M3. It should be an M3. It doesn't need to hold on to that much stuff. So it's going to be 3 millimeters minus tap hole reduction. Okay, and then let's add a helix to this. And a helix to this. We need a better way of doing this. I don't like, because the thing is the thread creator adds a bunch of like, the thread creator adds like crap. Okay, I'm happy with this. All right, so I think we're done with this part. So let's go back. So now it's time to add. So what is the distance between there? So let's go back. Wait. Forward. Okay, so from here to the underside of this, the min distance is 5.9. So we want to add like a M3 by 8. The shortest thing we got. M3 by 8. Okay. M3 by 8. So we can go back. Insert M3 8. And then can't I like just click on these? Click insert. Oh, heck yeah. See, now that's what I'm talking about. That's great. Wait, so let's just do that again. Okay, so boom, or wait. Boom, 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 boom. Heck yeah, that is great. What is the This is 6, so we get 2 on there. Let's just see what we got on here. Having 2 mils to hold on to is not amazing, but honestly, it's not that bad. Yeah, these are the 8s. Okay, I'm fine with that. It was like the smallest chamfer ever, and they're M3s. It's so brutal. Plus, this thread is not that good. Okay, cool. So now, what did we want to do? I guess, okay, wait, hold on. We need to think about this. So first off, I believe... Okay, so those... Does it show helices, though? If I hide this... It doesn't show the helix, which is kind of annoying. But so these are... Okay. What is this? It goes from here to here. It's 25. All right, so we're doing an M3 by 25. Or M5 by 25. So we go here, M5, 25. And then we want to go, what are these? This was 5.6, so these are M6? No, that's crazy, but whatever. M6, and we can do just by 8, I think, right? Okay, wait, hold on, let's do this. Let's do this, and let's just hide them. So we take this face. Wait, am I doing a mate right now? What is happening? Okay, yeah, so that's fine. We can do an 8 because we really, I mean, I don't even know if I have an M6 by 8. Let me go see. I don't know why I made these M6. I made these beefy as heck for no reason. Okay, so the smallest we got is 12s, but that's fine. So what we're going to do is insert M6 by 12. And we're going to go boom, 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 boom. Okay. Oh, wait, but these are hex, so I actually want to undo that. So instead of socket, they're hex head. Yeah. What? Dude, this is so ridiculous. Okay. Wait, but that's not even what they look like. Flange. Still not what it looks like. Still not what it looks like. There. Just a standard hex head. The thing is, I don't even know if that size is right. And of course they don't have my size. Great. It's so nice. That's why this thing is so stupid. I don't even know what that means. There we go. Maybe. Fine pitch. So that looks good. That looks good. I'll do that one. So we actually want to take this one and delete it too. Oh, because there's two assemblies? Okay. All right, so basically, okay, so my theory on how you want to do this is that I don't want to put in these bolts because these bolts should go in at the next level up. I guess that means in full, but there should be something that's Y and Z or something. It's like, how do you define the correct tree, basically? And then how tall are those supposed to be? I think I used 10s. I'm pretty sure I used 10s. And I want to see what their diameter is. 5.6. Yeah, that's right. This goes too far. We could cut this out and get some better access because it was such a pain to get these nuts in. It's so hard to get these in here. But I think that this part is good. I don't think I'm adjusting this part at all. Okay, cool. All right, so let's go back to full. So I believe we have. Why is this hidden? Okay. Are there any threaded inserts in this part? This part needs to be redesigned. But there's no threaded inserts there. Okay, we need to adjust this part. I believe that we need to adjust. Oh, you know. Oops. That looks like a. That could go either way for me. What is it? That's tapped. No, that's a threaded insert. What about this one? There's only one threaded insert on this part, I think, and it's right there. And it's because it's blind. That's basically my criterion now. If it's a blind hole, I'll put a threaded insert in it. Otherwise, it's good. Um, Okay, yeah, so we have a whole bunch of work to do here. Okay, so let's just start with the bottom. Okay, so first off, so this, wait, this part, wait, are these tapped? So those are tapped. And those are just for the bearings. Okay. Right. Okay, we do need to put those in. I think that I forget what size these are. Oh man. Okay, we gotta change all the parts. Okay, so they're all gonna take M3s, but the question is, I think it needs to take a 12, right? Maybe this is a... Wait, what am I doing? That's a 10. Okay. M3 by 10. Yeah, that's perfect. So then all this needs to be... So we're gonna go here. Specifically... Wait, we're talking about this right now, though. What? That's weird. What is that? Oh, okay. Does that change this one too? Okay. And now we just got to get that top guy. This is a threaded insert. So in the Z holder, and what is it? It's not a big deal. We can figure this out. Okay, so this is 7.6, so it's 8. This is definitely an M6. Wait, so wait. That's the outer, and the depth is 8. The depth is 8. And this outside was 8 too. Okay. 688. Okay, cool. Wait, where am I? I'm in Z. Okay, insert. So ID is 6, 8, and 8. The pitch I don't really care about, but okay, then you do the outer circle. Nope. This is still the worst experience ever. There we go. Okay, let's remember. So how long are these? Let's just take them out and we'll figure it out. Whoa. Wait, really? I didn't even know I had these. Are these in? Oh, wow. M3 by 5s. Okay, fine. Who cares? Not a big deal, but that's what they are. Standard content. Socket head. I think that those are correct. Okay, M3 by 5. Then we go bam, bam, insert. Okay, then these ones on top of here, I guess I need to measure a little bit because from here to here is 6. We want to make them as small as possible. We probably want to do 8s. We probably want to do 8s. Wait, did I just, no, restore it. Come on. Okay, then we want to do insert M3 by 8. Go bam, 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 bam. Okay, and then here, these are longer, I think. These are, I think, 10s, right? So then we go insert 10. And actually, you know what I want to do? Yeah, so let's just do 10s. Wait, what is this? Yeah, that's not right. Can we just delete that? Wait, both of these are wrong. Okay, then the Sharpie should have gone on here, actually. Okay, and then these seem wrong too, because these are threaded inserts in here, but we're going to change that. So we need to go switch to top of spring. It's not even spring. Let's take this. All right. And then bam, bam, Min dist 7.5. So we'll make I mean, technically 8s are good, but I'll just make them 10. So we go back. Please change, please change, please change. Come on. Change already. There we go. 2.6. Perfect. And then I think that are these M3? Okay, those are M3 too. So we can just put, and the thing is they have to go from the back. Right. So okay, so we're gonna insert, and I think M3 by, where did this 5 get used? Oh yeah, we don't have a, oh, and that's actually a threaded insert in this part. So wait, hold on, what was I doing? I forgot. Because it's blind. This part is actually brutal. You're gonna have to remember what we did. Self-tapping. You kind of need a lot of parts in this. Okay, we're doing the back of the servo. We'll just calculate it like this. 6.3. So we did an 8. Okay, cool. So M3 by 8. So we're gonna go like this. We're gonna go like this and this, and then click insert. Okay, couldn't figure it out. Cool. It does require a lot of fasteners. It's kind of insane how many fasteners you need. Okay, so wait, if we hide this... Wait, can we switch to? Is this an assembly? No, it's not. And we should fix this because this part is technically bad. You have to break the arms off of it, but I'm not doing that right now. This is just going to be... Okay. Just move this up here. So first off, let's hide this. Then we need to insert, and then let's just figure this out. It's so annoying that you don't get measurements. I don't know why they stopped giving you measurements. All right, so this is M3, and what's the depth? This is our standard, 3, 4, 5, I think. Yeah, it's the 3, 4, 5. So we got to insert the default 3, 4, 5. Oh, shoot. And then how long is this bolt? Looks like 12. Yep. It's funny how you get good at this kind of stuff, huh? So wait, let's go and re-enable the crank slider arm. And then this is yeah. Okay, cool. So then we just want to insert standard content, M3 by 12. Okay, and then the last thing we need to do is we need to find I think I put them on the closest. No? I guess I have just barely room. All right. So wait, we want to do insert self-tapping screws. Holy shit. None of these are right. That's crazy how little they have here. Wait, maybe it's just the length that's wrong? ST. Who knows? Let's just try to insert one. See what it looks like. No, these things... What? This isn't pointed at the end? Oh, because I did type F. Sure. That goofy as hell, bro. That goofy as hell, brother. But whatever, we're gonna put it in. Okay. All right. That's pretty much that. Wait, where did the threaded insert go? What? Where did the threaded insert go? That was weird. All right. Cool. Your boy's getting kind of good at CAD. I'm pretty sure I need to reprint. I feel like I should just reprint every part. I think this part's good. I think the pen holder is fine. The pen holder is fine, but everything else is not. But we're getting rid of the tyranny of the threaded insert.
Hey, you need a car today? No.
Someone did this exact project. It's like someone did the exact project, bro. I built a robot that can draw anything. There's so many better freaking ones than mine. It's just not a unique project. Plus, this one, I don't think he did any of the CAD. I think he just bought the stuff and put it together, but it's like, who cares? But I do want to see their Z-axis, because that's the thing that I care the most about. Oh my god, what a freaking terrible sound. How does this work? Wow, FreeCAD user. Good for you, using FreeCAD. It's like the exact freaking thing. And it's way better, too. It's like, in some ways, like, you can put way more work into a project and still have it be worse than someone that just found it online. I still feel like I learned something, though. And the other thing is he bought way bigger rails. I knew I should have gotten bigger rails, because bigger rails would allow me to do, well, bigger drawings. But also, oh, it's so cold outside. All right, I gotta lock in, dude. You gotta finish this. I'm pretty sure, let's go to full. How close am I to being done with all of the fixtures? That's in, we need a pulley wheel. I think that's just missing. Wait, are those missing? Or did I just not put those in? Okay, so let's go do that. Okay, insert. We want the, oh wait, but we didn't want them here. We wanted them in the, you know, I'm just going to put them here. What's the big deal? Standard content. Socket head. M3 by, I think we're doing 10. Okay, and it's going to be like this. Boom. 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 Good stuff. Okay, let's go back to full. I've been putting off the actual part that we need to do. Like, where is this coming from? Delete this. Where are these random screws? And there should be a random bolt somewhere. I don't know. I don't know why this thing is. But this is an X. Okay. Slowly but surely we will get there. How do I hide these mates? How do I hide these mates? We kind of just... Okay, oh, we need these too. Well, okay, it's time to redesign this. It's time to finally finish this project. This is going to be the last freaking time that I print everything. This is going to be the last time. I swear by it. See, that only got 4K views. That's the crazy thing. I built a robot that draws stuff. Now, that's actually not a bad idea. No, but then you gotta get it over it. Well, if it's the right length. I don't know. I'm not changing it now. It's so freaking cold. think pretty much everything's fixed. We literally just need to hop in here. Okay. So wait, so it was literally just was it just this? I think it's these, right? I want to make sure I don't change anything. Okay. So that was extrude 11? No. 12, 13 helix. Okay, so we just need to go like this. This is going to be the bad tensioner, and we're going to suppress that. Okay, so now the thing is, that idea is what we're going to do, but we just need to be smarter about it so that we don't lose travel. So what we're going to do is make this part unnecessarily big. You know what? What about this? Let's find this slot. Let's change the slot geometry to move it back. We're just going to put the hex head in the middle. I don't even care if it's going to be jank. I'm kind of worried about this, but we're going to try it. We're going to try it. I mean, what's the worst that can happen? So it's this sketch. Okay, so we're not doing this thing. We're saying that this... Let's just make this like 3. Okay, now the slot is way back. Now, what we're going to do is we're going to make a plane. So we're going to do plane. It's offset. It's going to be offset the other way, and it's going to be the hex head depth. But I don't know if they're all the same depth. So we need to actually get the specific. We're just going to use an M6. Just use the biggest one. Who cares? So this is an M6. It's 4. So I'm going to go to params. We're going to do this the right way. We're going to do this the right way. See, the other problem is that like when you use standard content, you don't have them as variables, but like you need to plan around your hardware. M6 hex head depth. I'm going to say this is 4. Okay, so what we're going to do is we're going to make an offset plane. So wait, first off, we need to go to params, version, create version here, reconnect, then... All right, I'm getting the workflow, but it's like today is seriously a slog. And it's just because I'm like, I don't know, I'm like kind of tired. I like really wanted this just to work, but like everything sort of went wrong. Okay, I don't really care about all that. So we want this to be a hex head depth. Did we flip it? Wait, what? There we go. Okay, now we're going to sketch on here. And we're going to use the outside guys, right? We're going to use this, this, and this. Okay, now we're going to draw a rectangle from here to... I guess we want to use these two, right? And then this point and this are midpointed. Okay, then the dimension of this line is going to be 10. And then we're going to take these. Oops, not that, but I guess this. Extrude it. And extrude this. We're going to flip the direction. Oh, I guess we need to compute the distance, right? Is it going to be 10.8? We're going to do this again. So we're going to say from here to here, its min distance is 14. Did we really get that much extra? I want to change this plane to be like +3. I want it to be back further. So from this to this, the min distance is 11. All right. So we're going to extrude this, add, flip it, 11.6. Okay, we're going to try this thing. We're going to try this. Who knows if this is going to work? Okay, so nothing should be sticking out there, but it does allow you, okay, so that's fine. Oh, wait, we don't have any of this. Wait, do we? In the assembly? I think we have that, but we don't have, oh, wait. You know what we don't have, though? We don't have the nut. Okay, I want to do that real quick. So on X, we need to go to X. Okay, I want to hide this. Okay, and then we need to move this out of the way. What? Okay, now we want to take this, hide that real quick. Insert, standard content, nuts. Hopefully it keeps the same. Okay, so then this is going to be an M3. It's the thin grade, right? And then we just need to select. I wonder if we can select that face and do insert. Nice. It's kind of... Did we get this depth right? Because you kind of want it to be... Well, whatever. As long as there's... Oh, see, wait. But it rotated wrong. Whatever. It's close enough. We can turn back on this. Okay, now let's take this, hide this, insert. Nice. Look how well documented everything is. This is too long, though. I think we're doing 20s. Okay. This is such a jank thing, but it's okay. All right, so we're finally ready. Wait, why am I in the assembly? I think I do want to do it off center, but hold on. We need to, because if we're using a big ass, okay, I am going to do it in the center. We're going to see if that works. If that doesn't work, I'm going to be sad. But you know what I could do alternatively? I could add holes here to mount this. This is the funny thing about prototyping. It's like, do I make this a separate part so I can modify it? Okay, so it's 11. So let's just make a circle. Wait, are we on this? Oh, yeah, it's going to be like... This is a big-ass nut, dude. So that's what that hex head is going to look like. Ooh. Okay, so we're going to make it an M5. No, we're going to make it an M5. Let's see. Let's go. Do we have an M5? Yeah, we do. This is an M5. Oh, and it's way better. Yeah, it's like 9. Okay, then. All right, so that's it. That's what we're going to do. We didn't even have to make it longer. We just moved it back. And hopefully that will give us some clearance to tension and not lose travel. Bro, am I kind of... Hey, what's up, Riley? Bro, today's been a tough day, I'm not going to lie. Just a bunch of stuff has gone wrong. The belt tensioning mechanism is no good. It's just too cumbersome. The slot that we added here is like super frustrating to get the supports out, so I added this thing. This counterboard diameter was too small. Luckily, I was able to like ram it in there, but I mean it's moot now. What other bugs did we fix? Let me go to the version history. Oh wow, it does have all the changes in here. Tons of changes, but I think... Does it show... Instead of a slotted nut... Okay, oh yeah, added more room because it was impossible to install these... Yeah, oh, did we even counterbore that? I don't even think we did. I don't think it's necessary, but that is funny that we didn't even do that. Okay, I don't care. So, let's just go back to full. And all we need to do now... What the hell? Let's move this over. Okay, so what we want to do is we want to... All right, I do want to do this. So it's going to be insert M5 by 25. I think that's the longest I have. Oh, but the problem with doing it this way is we want... Okay, hold on. All right, I think I'm just going to put it like this. So wait, so we have this rim, and then we want to go to the center of it. I lost it. Where did it go? I just put it in the center. Nope, not what I wanted. What is happening? Wait, I had it. I had it. I just got to go up a little bit more. There we go. Bam. Okay, now what we want to do... insert the pulley wheel. Oh, wait, let's do the nut first. Wait, 25. Oh, no, you know what? I think it's a 30. Wait, hold on. First off, it's a hex. Let's see, where did that thing go? This is a 30. Okay, wait. Can we... Oh, wait, restore. Wait, you know what I want to do? I just want to go... Wait. See, we're doing this in the wrong place. Where's the other one? I need to delete these. Okay. What we want to do is we want to go to X. Switch to X. Insert. Let's turn this rail back on so everything makes sense. Okay. Wrong side. Okay, it's an M5 by 30. We're going to insert it. Why is this navigation being so hard on me? It'll load. Give it a second. Okay. It keeps giving it to me and then it tears it away from me. How do I get it? Oh, I had it. You know what I'm going to do? I'm just going to go like this. How do you stay on the face? There we go. This is actually, so it's actually a slider. So why don't I actually model it like it is? So it's a slider. Let's play it. Ugh, damn it. All right, let's just make it fastened then. Be too much work. All right, we put it at the back, but that's fine. Now we just need to insert the pulley wheel. Oh wait, let's do the nut. This is an M5 nut. We should just be able to, I don't know, like select that and insert. What? Why is this so bad? Ugh, whatever. Just leave it out. We just need the pulley wheel. I just want to see what the pulley wheel is going to be like. Okay, which way does it need to go? Okay, it needs to go... Alright, so let's just insert it. Then we're going to mate this. Oh my gosh. To here. Ugh. Shit. Why isn't it letting me do this? There we go. Okay, wait, but how did I do this before? Oh, it's because, you know what I need to do? I actually need to do it like this. I got it. No, no, no. Oh, I had it. Bam, that's it. Cool. Okay, so what's going to happen is we should probably move this to a new subassembly so we can just look at it closer. But a helical, a nut is going to go in there and push on this thing. And I'm just worried that the nut, it's going to be weird that the full contact, it's not going to make full contact with something. But then I don't want to put it off axis either. Anyways, we're going to attempt this. We're going to call this done. We need to figure out which parts I need to export, because I need to export pretty much every part. I don't know who else is here. I think Ola's been popping in and out, but that was like an hour and a half ago. The thing is, I've been a little demotivated today, so it hasn't been that engaging because I've just been like going to sit in the sun and stuff. I had to make these bigger. All right, so let's just, okay, so let's make a new version. This is V6. Added a ton of fasteners. Fixed the peg diam because it broke. Made a mechanism to use a lead screw, or to use a bolt to tension the belt to move it along the slider. Moved the slider back on the idler so that the bolt that tensions will not reduce travel. Converted a bunch of usages of threaded inserts to tapped holes. Pretty much the only time an insert is used is on blind holes. What else did we change? I think that's pretty much. I think that's pretty close to what it is. So we're ready to print, but it's gonna be like, I think I'm gonna have to make like. Have I done my homework? What homework? Are you talking to me or Ole? Okay, so I think I pretty much have to reprint every single part. We're gonna see how much I can fit on a single thing. The only part that I really don't have, there's only two parts I think that I don't have to reprint. Well, okay, I'm not going to reprint this part because the only thing that's different is this. And slightly this. I made this gap a little bit bigger, so it's potentially easier to get the bolts in. But we're not going to reprint that. We do need to reprint this, so we're going to export this. This process is so slow. Okay, so we got V6 on that. Okay, now we need to reprint this. So we're going to export this, V6. Oh, and I guess the nut, but I'm not going to worry about that. We already got it in, so it's like, okay. Let's see. Okay, so let's go to full and just do it from full. How do I hide these mates? How do I turn off the freaking mates? It's so ridiculous. Alright, I don't care. Okay. Okay. That's kind of most of it. I guess I could reprint this. I could reprint this. But it's like, do I really need to? They haven't broken, so I'm not going to reprint them. Alright, so let's just... so I'm not even going to print this. I'm literally just going to print this and that. So this shouldn't take that long. So we need the X-idler and the carriage. And I hate the freaking supports, man. I'm so sick of supports. Can we get away with no supports? I kind of want to see. I've done this enough times. Alright, the fillets are still there. Everything's looking good. All right, we're going to try it with no supports. Living on edge. I believe those are the only two parts that I really need. Edit a video. Dude, oh, guys, now that you're here, I found this video. I built a robot that can draw anything. It's like, first off, this thing only got 4K views, but it's a good video.
World. In this video, I'm going to be attempting to make a robot that can draw anything. If I tell this robot to draw...
I think the audio quality is a little bad. The intro's not that exciting. But it's like, a drawing robot in general is not that exciting, I feel like. It's like not that cool. So...
this robot to draw a robot, drawing a robot, it will draw it. How am I going to do this, you might ask? I am so glad you asked. I got my plan right here. I'm already 80% done with it. Let's keep going. I've done some research and I've learned that a drawing robot is part of a family of machines called CNC machines. I'd tell you what CNC stands for, but nobody cares. To build this drawing robot, I'm planning on using parts that I found around my home, such as
it's like pretty
rails,
funny.
A pulley system, and stepper motors. I'm going to use an Arduino to control the stepper
motors. The thing is, I don't think he did any of the CAD himself. Link, please. All right, so I guess we're just going to wait for these two parts. And I think that these are the only two parts that I'm going to need. Let's hope this no support thing works out. It's a pretty good video, but like, it got no views. Like, if we're going to put so much effort into this thing for 4,000 views, that's like not worth it. I could make a YouTube short that gets that much. I do think that there's a number of things that we could do to just like increase the appeal. Thumbnail, you know, whatever. But he's got the name for it. He's got the googly eyes. He put a top hat on it or a fedora. He did a lot of the gags that I was going to do. And it just didn't get that much traction. It's just boring. It is a little boring. I think it's a little quiet. There's not enough jump cuts. It's a little boring in terms of pacing, but it's a pretty good video. But that's the thing, is like just getting the video to be entertaining is a feat, an engineering challenge in itself. For sure. Oh, bro, I just want this thing to be... He edited the shit out of the video? You mean like in a good way or a bad way? Yeah, you can tell he leaves out a lot of stuff though. Okay, guys, let me show you an example of one of my favorite videos. All right, and we can talk about this. I'd love to talk about this. This guy is awesome. He built this sick... Oh, dude, this video is quite literally one of my favorite maker videos. All right. I think that this video is an example of like kind of how to do it perfectly. 1 million views. Oh, and he's so genuine, bro. I feel like I just want to shake his hand. Danny Loom is so good at doing this style.
Capable of tracking humans and shooting them on sight. Killjoy is Valorant's genius German engineer.
And he because he has the perfect overlap, right? He does the thing where it's like, okay, first off, cool engineering thing, plus it's from a video game, so everybody loves that. You know, everybody loves something from a game that they play. He does such a good job.
Lockdown defense. I built an auto-sentry turret that is capable of tracking humans and shooting them on sight. Killjoy is Valorant's genius German...
Dude, he's also like goated at CAD. Like, his CAD skills are crazy, bro. He's so good at CAD. It's almost upsetting how good he is at CAD.
Engineer in the yellow puffer. She uses her sentry to play lockdown defense and pick off enemies. And I made a fully functional prototype of her turret. Since you guys...
And the paint, dude, like the paint, he does the work to make it like so cool.
Blew up my last project, Boomy, I was able to partner with Red Bull for this project. In 6 months, I brought the turret from game to reality just in time to travel to LA, film with Red Bull and Keo, and attend the Valorant World Champions tournament. Let us begin. We're going to start with the shooting mechanism. I wanted to have enough power to shoot someone across the room. I ordered this gel blaster and I think it's going to be perfect. Let's test it out. This thing shoots super fast, but it definitely jams, so we're gonna have to tinker with that to fix it. My plan was to put the gearbox inside the main compartment of the turret. There also needs to be a large hopper to put ammo in this cylinder. Now the question is, how do we transfer rounds from the back in the storage container to the front to be shot? I found this motorized magazine and I thought I could recreate my own that loads Orbeez through a feeding tube. Also, the Orbeez jam super easily, and Chicken Skunk from my Discord gave me some amazing advice. I'm new to the blaster community and he recommended checking out Nerf Rival. Out of darts.
That's what I use, bro. The Nerf Rival. Wait, is chat dead? Okay, cool. Yeah, I'll give you some time.
The way it works is that a feeding motor pushes rounds one at a time through the chamber, where they meet the flywheels that spin super fast and propel the round forward. It also uses a vacuum hose to transport rounds jam-free to the blaster. I purchased my own proton pack in Jupiter.
He bought the proton pack, which is so smart.
Impressed with the quality.
But he catted everything else.
Freaking awesome. The motors spin at 35,000 RPM, or almost 600 times a
Oh,
second.
the hacksmith, bro. The hacksmith has too many resources.
In the handle.
Guy's way too freaking good at it.
Control how often to shoot with software. Let's test it out.
I just built the level 2 sentry turret from TF2, a chain-fed, face-tracking, AI-powered minigun turret capable of shooting over 200 rounds per minute.
200 per minute? That's not that many.
The holidays are approaching, and that means it's time for one of the biggest YouTuber collabs of the year, the Maker Secret Santa Gift Exchange. And if you're not familiar, I'll link the playlist below. But basically, some of the best maker channels on YouTube get together, are assigned a random YouTuber, and we make some amazing Secret Santa gifts for each other. In the first year, I made a nuclear red phone to connect all the YouTubers' workshops together, just like the red phone that the president uses. I'm extra excited about this year's video because the name I drew is Mr. Volt. And I actually met Mr. Volt at OpenSauce for the first time back in 2022 and was super impressed by his projects. He does make real solid content too and made an absolutely incredible Wheatley from Portal. We've even chatted about doing collabs here at Herc. Now, one of his past projects from just a few months ago was building the level 1 sentry turret in Team Fortress 2. So for his Secret Santa gift, I'm gonna level him up, literally, and make him the level 2 sentry turret. The mini sentry turret features just one gun, but when you upgrade to level 2, you get 2 chain-fed miniguns and a large ammo holder off the back. It's pretty awesome, and once it's set up, it automatically tracks and shoots your enemies. Now, the only B-roll I could find of this turret was for the blue team, but everyone knows the blue team sucks. So for DJ, we're gonna go Team Red. Step 1, we're gonna need some guns. Maybe not real guns. I think I have some off-brand Nerf guns that are actually chain-fed. We have some Nerf guns here somewhere.
The hacksmith is NASA guy edits. Well, okay, yeah. I mean, but Mark Rober has like 60 million subscribers. It's kind of like not comparable, but I get you. Also, I'm surprised at how boring this hacksmith video is. It's like not a lot of quick, exciting jumps. It's just kind of like
Chain-fed Nerf minigun.
it's pretty authentic.
This off-brand, belt-fed Nerf minigun is perfect for our TF2 turret.
All right, it's pretty simple inside. I need to power the gun remotely, so I'm going to put in this wire, stick it out the end, connect the black wire to the black wire, and bypass the switch by soldering this guy on right here. The button still works. And if you just give it power, which is what our little PCB will do, it also shoots. We can also up the voltage to make it shoot faster. The only issue, though, is this chain is pretty short. It only has about 40 rounds. But since this is an off-brand Nerf gun, you can't just go out and buy more chain link. But luckily, I'm standing in one of the best equipped workshops in the world, if I do say so myself, and I should be able to reverse engineer this and manufacture my own. Step
Dude,
one.
no way he's gonna do that. He's gonna 3D
Let's
print
create a
it.
3D model of the part. Now, there are ways to 3D scan stuff, but if you want to change anything, it's a lot easier to just design it from scratch. And all you really need is a nice pair of calipers.
Midatoyo, bruh. You gotta get that Midatoyo.
If you've never learned 3D CAD, I'm going to let you in on a secret. It's really not that hard to do. All CAD software is ultimately the same at a base level, which means it doesn't even
Except for Mastercam, the
matter
stupidest
what
CAD
software
ever.
you use.
So glad I dropped that class.
I use SOLIDWORKS because I've been using SOLIDWORKS for nearly 20 years now, and SOLIDWORKS for makers costs about the same as a cup of coffee a month to subscribe to. And when I first learned SOLIDWORKS decades ago, licenses cost tens of thousands of dollars. So it's pretty awesome that it's accessible to everyone now, and not just businesses. Anyway, as you get more proficient at CAD software, you can use fancier tools and be more efficient in how you design things. But the most basic features you can use and model for parts are two simple tools. One is called Extrude Boss, and the other one is called Extrude Cut. At the core, this is basically just a cylinder. So we're going to measure the diameter of the cylinder and the length. So we're going to create a circle, and we're going to dimension
Wow,
it
see,
15
dude, okay, what do you guys think about this? This video is so boring that he literally hops into CAD in the video. He literally hopped into CAD.
5, and then we're going to hit Extrude Boss. And we're
I
gonna
kind
do
of
it
love
55
this
dollars.
video
And
though, because it's not like, it's not cringe Mark Rober, boom, boom, boom. You know, it's just kind of like, here's how you do it.
And as you can see, we've got a cylinder.
I kind of
Super
like
simple,
that.
super
You know, I used to think the hacksmith was annoying, but he's kind of just awesome.
easy. It's a bit more complicated than that. It's got these lips and ridges. So we can just do Extrude Boss again. Make another circle, and this time it's 20 millimeters, 2 millimeters thick, 2 millimeters. Make sure we're going in the right direction. So right now it's actually going the opposite direction. Switch that over.
It's crazy. It's like a CAD tutorial. What the hell?
Bada bing. Repeat that on the other side. Now we're going to do Extrude Cut, which, as you can guess, is basically the same as Extrude Boss, but it removes material instead of adding it. So we hit Extruded Cut, click that surface, add a circle, and measure it, 14 millimeters, and measure how deep the circle is, 54 millimeters. And now, as you can see,
Let's do
we've
a
got
deep dive
the
on these
basic
guys.
rough outline of this. And now we can add all these other features the same way, essentially, just by extruding those shapes at a dimension that you measure with your calipers. That's the basics. And it's really not that hard. You just have to start. And there are tons of amazing tutorials online, great YouTube videos teaching you how to do CAD, and knowing how to do CAD and having an awesome 3D printer like these Bamboo Lab 3D printers means you can design and make whatever. So let me finish the design and I'll show you how it was basically just two tools. Boss, cut, fillet, boss, cut, boss, cut. It's really just that simple. And then just because I also wrote Hacksmith Arms on the top, which is kind of cool. The next part of reverse engineering is making sure that you measured stuff right. And what's the easiest way to tell if you measured stuff right? The beauty, again, with having 3D printers is I can send this to the 3D printer, and there we have it. And now I can make sure that the dart fits. So while the main design was pretty quick to do, I had to fine tune the dimensions a little bit to make sure everything fit just right. First design was too loose, then it was too tight, then it was a bit too big, and then finally just right. Now, the issue with this part is printing them individually and using support material takes a lot of time. So I want to challenge myself and redesign this in a way that I could print it without support material. Now, just like the first design, I iterated it until I came up with this, a flat surface with no support material.
Dude, this is the kind of video that I like. Awesome for a... What's an NER? Awesome for a nerd like me. Is that what you're trying to call me, a nerd, bro? I agree. Well, okay, let's go to his stats, though. He has 15 million subs, dude. All right, let's watch his most.
Bring me.
Dude, I don't know why people like superheroes so much. I don't get the appeal. I think it's kind of lame, actually. Marvel and whatnot.
Wakanda forever.
guys, it's finally time. I've finished training to kill Thanos, which means it's time to test our Stormbreaker build. Stormbreaker! But first, in case you guys haven't been following along, this is Make It Real, and I'm your host, the Hacksmith. We take fictional ideas from comics, movies, and video games and make real working prototypes using our engineering know-how as a way to inspire you guys into science, technology, engineering, and math. Marvel is one of our favorite sources of inspiration, and you might have already seen some of our other projects, like Captain America's electromagnetic shield, his Wakandan shield, Thor's hammer, complete with all of its abilities, Hulk's fist, and even Iron Man's arc reactor.
You know who else is really crazy? Is Jay Laser, bro. This guy's wild. That ink thing that he built, dude, that was
In this
crazy.
vat is a bunch of moving black ooze that's probably the closest thing to venom you've ever seen. Now, if I get close enough, it jumps onto my arm, defying gravity, and eventually cover me from head to toe, just like in the movie Venom. So what is this stuff, and how is it happening? It's called ferrofluid, and it's got some amazing properties that make it perfect for creating a real-life liquid venom suit. So the reason ferrofluid can move like this is because it's magnetic. So as soon as we put a magnet nearby, it immediately springs to life and creates these awesome shapes that actually show the magnet's field in 3D. Super cool stuff. It was actually originally invented by NASA as a way to inject fuel in zero-G. Their solution? Make the fuel magnetic. So they made ferrofluid, which is basically tiny iron nanoparticles that are magnetic, suspended in an oily fluid. It's a little too convenient though. It's NASA from space, brought back this venom, also from space. Depending on the magnetic field strength and orientation, you can make some awesome shapes. It's also got this ink jet black shiny look to it, which makes it even cooler. There's also different colored ferrofluids, like this red stuff right here. That is a red one. So it might even be possible to make a Carnage suit as well. Now, if we get the magnet a bit too close, it'll actually jump onto the magnet, completely engulfing it, just like Venom does to his human host. So the plan is to take this to the extreme and hopefully make the closest thing to a full Venom suit in real life. And I'll be honest, I didn't want to make this video. I still don't want to make this video. This stuff is a nightmare to work with. Oh God, fuck. It gets everywhere.
What'd you do? Dropped it. What did you do? I dropped the ball. What are those?
What, like, best case scenario, I end up covered in black slimy goo. It's just not gonna be fun. But in my last video, I made the mistake of showing a clip of this stuff. And now all the comments are challenging me to make a full Venom suit. While I hate to admit it, it does look really cool. So if there ever was a time to do it, it'd be now. All right, but
How does he
in return,
make
you
it?
guys gotta leave me a comment for what I'm making next. Let's just start simple. Who knows, maybe it'll be easier than we think. First, we're gonna need
Smooth brain shit for groths? What's groths? What is a groth?
a bunch of paper towels. Now, I'm basically gonna mummify myself. Wrap me up, don't be shy. Stand in a bucket of ferrofluid and let capillary action do the rest. Same way that trees can pump water hundreds of feet in the air without moving at all. Probably smarter than a tree.
I'll hold it with my tongue. Answer biting me.
Get him. Yep. Ow, ow. I mean, if trees can do it, why can't we? All right, you ready for this? Oh. It sucks. We had one job. Oh. It'll get there. I was really hoping it would just whoop, and we'd be done with this. Come on.
To do one last message that I've been thinking about.
You're not gonna dump it on me.
Come
Oh, Venom, what if we just did this? Oh, I just have to blur it. Yeah, it doesn't work. This would just take way too long to completely cover me. We don't have as I hoped. We gotta fix that. So my next plan is to use magnets. Like this neodymium magnet right here. For this demo, I'm pretty much just gonna hold on to it. And once we get close enough, the ferrofluid will spring up on my hands. If that works, eventually we'll make it cover my whole body. 3, 2, 1. Oh, whoa. Dude, look at that. Wow, that's freaking weird. This is so weird. Ooh, that's weird. Do you think
See, the thing is, it really matters for growths. See, the thing is, it is just really a great idea. That's what it comes down to. Just a fantastic idea.
It's super hard to watch.
It's so cool.
All over you and everything you touch.
Kind of objectively cool.
Yeah, all right, let me do one where I'm recording. Yeah, it's recording. So what do we learn? This stuff is fucking messy. Fucking soccer star, Loch Ness Monster messy. Too aggressive today, man. I go, toss me a cut shirt. How's it look? My God. Now, beautiful. I sent a couple of these things over. I've been wearing them every day. You've probably seen them in my last like 5 videos. Check them out below because these things are clean.
All right, anyways. I wanted to watch this. I like this style way
It
more.
also gave me an excuse to try something that I've been meaning to try. Have you ever seen a wall-mounted conveyor belt 3D printer? I wonder if I could feed it directly into the gun from the conveyor belt. That conveyor 3D printer isn't actually that good, so I decided to hedge my bets, and I also designed it to be printed on the Bamboo 3D printer. And I can actually print 40 links in about 8 hours with about $2 worth of plastic. And the neat thing is, it's also print in place, which means the link is ready to go right off the 3D printer, and then you can quite literally...
Dude, I need to do
attach them
more
together
print in place stuff. Print in place is so cool.
and add as many as you want. Look at all that chain. Now, I've actually uploaded this 3D model to my thanks page, so if you happen to have an X-Shot blaster and you want more chain links so you have more ammo, Check out the link in the description below and you can download it for free. The thing is, I don't like how this looks with half the dart being exposed like that. Mr. Volt's attention to detail is second to none, so I'm actually going to 3D print the carbon copy that I made using our new Formlabs Fuse 3D printer, which is a super
No
fancy
way,
3D
he has a
printer that lets you
fuse.
cut parts
Obviously he
of
has a
material
fuse.
by laser sintering fine nylon powder. And once you've blasted off the parts, you can actually dye them with plain old fabric dye to make them look even better. And that's how I came up with this. Custom Hacksmith Arms Nerf chain. And
It's made out of nylon. Give me a break. Those things look too cool, man.
The gun at higher angles. Anyway, I've just spent like 5 minutes of the video just making a Nerf chain, and we're making the whole turret. So hopefully you're still watching, but don't worry, we're going to speed things up a little bit. Over the weekend at our company retreat at Big Shoot Lodge, I spent most of my time designing a 3D printable model of the entire turret using references from the game. Then, when I got back to my lab, I started the 3D printers.
This design goes the functionality.
All right, I think this is my Secret Santa gift, and it is from Emily the Engineer. Got big on YouTube by 3D printing a awesome Iron Man suit, and actually the very first time I met her, she was wearing it, and we were all at Colin Percy's.
You kind of only need one big video. It's a great example of how not to do it. It's like, it's so interesting because like, I don't want to just, like, if I were to do it the way that I want to do it, it's not going to do it. It's not going to go well. So yeah. But but the thing is, they got big somehow, you know? But this video isn't edited all that.
That's probably the closest thing to venom you've ever seen. Now, if I get close enough, jump on my arm, defying gravity, and eventually cover me from head to toe, just like in the movie Venom. So what is this stuff? How is it happening? It's called ferro fluid. It's got some amazing So in this vat is a bunch of moving black ooze that's probably the closest thing to venom you've ever seen. Now, if I get close enough, it jumps onto my arm, defying gravity, and eventually cover me from head to toe, just like in the movie Venom. So what is this stuff, and how is it happening? It's called ferro fluid, and it's got some amazing...
It's a pretty good intro. All right, let's go. All right. Okay.
This is
I think we're gonna decide that we're just gonna base it off of Mark Rober because he is the most successful. He's like kind of the GOAT at this whole thing, right? So if we can we don't have to like take too much data for a first video and just look at all of his robot videos.
This is Matt Prater. He's the place kicker for the Detroit Lions. He holds the NFL record for the longest field goal ever, which means he's really good at kicking footballs. And this is a robot I made, which, not to brag, is also really good at kicking footballs. So to settle who's better between the two of us, we're going straight to Detroit. Mano a mano, man. This is...
The first video, he got big because of those... Yeah, 1/15 view. Yeah, right. Yeah, that's a great point. That's a great point. That's a very important ratio. And it would be interesting. Yeah, you need the time series to go deep into it. But yeah, he got big because of them. This is 90 million. Oh, you're talking about Hacksmith. Yeah, of course, right. He got big and then he's like, you know what? I want to do it my style, but it's like, yeah. See, what was the thumbnail here? It was just a picture of the robot, right? Not his face. I guess I gotta have my face in it, right? Like, it's not gonna... Oh, okay, here's where we're gonna take the thumbnail from. We're gonna draw that picture. I'm gonna try to find the... I don't know how I'm gonna get that picture, but we need to get that. We need to get the really high. It's probably in the video, maybe. I don't know. We gotta find that picture though. This video is so good. Those squirrel videos, I kind of loved that actually. All right, yeah, this is one of my favorite videos ever though.
This is a bird feeder.
The first word, if the first word is not this, Imagine me getting 20 views. Yeah, that's a great way to put that. I didn't think about that, but that's a terrible day. If one of my videos get 20 views, I'm bummed the hell out. It's actually sucks. That's a great point. That's a great point. But this, at the time, he probably had way less than that.
This is a bird feeder, and everything you see surrounding me in my yard is an attempt to protect it from thieving squirrels. If they want the birdseed and the lifetime supply of walnuts in this bank vault, they'll first need to pass through my 9-part obstacle course. By design, it's extremely challenging. It's meant to test their mental limits and their physical limits. I held back no punches, but I have to admit in hindsight, I once again completely underestimated my adversary. And truthfully, I never thought I'd be that crazy guy in the neighborhood obsessing over the squirrels, but they started it first when they would constantly pillage the birdseed from any bird feeder I would put up about a year ago. That led to me defending it with an obstacle course which they handily defeated, and so after a year of ruminating on how to avenge that L with a majorly improved version, and then 2 months of planning, my buddy John and I got together for a 20-second build montage. Here are the basic elements. For starters, here's their favorite bird feeder at the end of the course, and it's sitting atop Fort Nuts, the most secure walnut vault in the western United States. Now, since birds can fly, they can come and go as they please. This is a bird feeder, and everything you see surrounding me in my yard is an attempt to protect it from thieving squirrels. If they want the birdseed and the lifetime supply of walnuts in this bank vault, they'll first need to pass through my 9-part obstacle course. By design, it's extremely challenging. It's meant to test their mental limits and their physical limits. I held back no punches, but
The other thing that's really, really nice about these videos is that the background music that they have there is synced to the scene changes. I like that a lot. It's very nice. I want to do that. What video were we basing this on? We were basing this on the what robot was it? It was a recent one, right? Oh, the puzzle robot.
this is Jigsaw. He's a friendly little robot that's really, really good at only one thing: putting together any jigsaw puzzle, no matter how complicated, really, really fast. It's taken us 3 years to get to this point, but according to our initial tests, we have hopes he might be 200 times faster than the fastest competitive jigsaw puzzler in the world. So today we're gonna walk through
Did they use the same music? Is it the same music? Am I tripping?
This is a bird feeder, and everything you see surrounding me in my yard is an attempt to protect it from thieving squirrels. If they want the birdseed and
it's the same song. It's the same song. That's so funny. Oh, we're just waiting on my printer, bruh. All right, this time it's gonna work though. This is the last time. I'm not printing all this stuff again. This is gonna work. This tensioning mechanism, bro. I'm a god if this works for real. What was I gonna do? I forgot. All right, so let's go back to the other one.
took to get ready for the ultimate robot versus human face-off, and along the way, we may just discover some tricks you might find helpful as a mere human jigsaw puzzler yourself. But before we unpack how Jigsaw does what he does, I first want to give us humans some well-deserved credit. Because while this seems pretty straightforward of me to be able to pick up and arrange these 12 pieces of a puzzle, I'm actually doing 4 very complicated tasks. The first is just picking up a piece. Have you ever stopped to think just how amazing our hands are? Hiding beneath that skin are 27 bones and 34 muscles, which makes them flexible and strong, but they're also incredibly
Okay, let's look at all the intros, because I feel like the intros...
This is Dom. He's a friendly little robot that's super good at only one thing: setting up a butt ton of dominoes real.
Where's my, wait, hold on. Where's my script at? I think I'm just going to start writing Mr. Plot. Okay. That's the first line. Arguably the most important line, right? Maybe the easiest line. We're going to be basing it solely on Mark Rober. I can't do too much like cross analysis for the first one.
This is Dom. He's a friendly little robot that's super good at only one thing, setting up.
Wait.
This is Dom. He's a friendly little robot that's super good at.
Do you think they added those fucking squeaks in? Or they recorded it? Maybe they...
This is Dom. He's a friendly little robot that's super good at only one thing, setting up a butt ton of dominoes really, really fast. This is Jigsaw. He's a friendly little robot that's...
It's like so formulaic. I didn't realize just how formulaic it is, but it's actually, it's one of those things that's like, it's so consistent. It's like part of the brand. This is Robot. Blah, 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 blah.
This is Jigsaw. He's a friendly little robot that's really, really good at only one thing, putting together any...
Should I put friendly? Friendly's such a stupid thing. He's a friendly robot. How stupid does that sound? But you know what? It's all about making it work. I really don't care if it sounds stupid if it works. But the thing is, you have to also separate. I am not Mark Rober. So it's like, if for me to copy Mark Rober, is you can't, I don't know. I don't have any data on this. Okay, this is Mr. Plot. He's a robot designed to do one thing. Take an image and draw it on a piece of paper using a Sharpie. I don't even need to say using a Sharpie. It's unnecessary. Okay.
Any jigsaw puzzle, no matter how complicated, really...
Wait, what am I doing? Why am I tripping out? Wait, hold on. Is it printing correctly? Okay. Seems to be going pretty well. What a day, man. What a day. So many epic failures.
really fast. It's taken us 3 years to get to this point, but according to our initial tests, we have hopes he...
I kind of want to do a shot because I have all the live streams. What I wanted to do was download all the footage from the live streams and then do like compress it down into like 5 seconds or something like that and go boom. That was whatever 50 hours of working on this. The thing is, it's not even that impressive. Like, this project did not take that much work. Quite literally did not take that much work.
Might be 200 times faster than the fastest competitive jigsaw puzzler in the world.
I want to just read it. Where was that script? I think it was on my other computer. Oh, but I didn't push that code to download it. Did I? Transcript grabber. Well, but you know what? I put it on Discord. Hold on. Actually, you know, I could just read it. I could just read it on YouTube. I don't even need to do all this. Ah. Okay, so you need a line that said, okay. Oops. Hello, hello, hello. Okay. Um. Yeah. Okay, what I'm trying to figure out is okay. So let's just like break down because all these lines have a purpose. So first off, the intro. It's just like the intro. But then this is basically an explanation of what's coming. So today we're going to walk through what it took to get ready for the ultimate robot versus human face-off. So I need a line that explains. What it took to design, assemble, and control this robot. I don't need this open. Let's see. We should calculate the BOM cost because it's like, okay, the bolts kit probably like $30. The stepper motors, like, okay, hold on. Let me get a piece of paper. Let's just write it on here. It's probably like bolts, 20 for bolts. I mean, this assumes that you have a filament and 3D printer. Okay, I guess the Arduino Uno. So maybe this is a little bit more expensive than I thought. It's because I already own all this stuff. How much does an Arduino Uno cost? Wait, isn't this the new one? Didn't they just release this thing? Wait, this is the... Dude, this has this old-ass chip on it. Where's the new one? Oh my god. Whatever, let's just say it's $30. $10 for the shield and drivers. I don't know, 30 for the steppers. Yeah, you can get the steppers for like that much. The rail, how much was the rail? Okay, actually, I guess I need the code open. I guess I can just work on documentation while I wait for the print to finish. There's so much work to do. Okay, so let's just make sure that there's. Okay, hold on. All of this stuff, data. I'm just gonna do this. README. What's new in README? Oh, light theme does this stupid thing where it hides my fucking... What are my changes here? Oh yeah, okay, let's just... Okay, let's merge these. Okay, so we did do this. We did this. We did all of these. Nice. I did this. I did this. Or we could use Z-axis to control rolling paper. Yeah, I'm not going to do that. Okay, we did that. 2 sets of microstepping. Didn't do that. Redesign the rail holder. Screws can actually be put in, and the rail can actually get fully surrounded. Okay, so we did this. This has a lot of the repeats kind of in it, but it's okay. Try to take a short video of it using an RPI camera or GoPro. Fix BOM. I do need to actually... I wonder, can Onshape generate a BOM for me? I should have all of the fasteners I need, except for these screws, these wood screws. I'm pretty sure I have everything. So I'm wondering... Let's just try to search for it. Wait, how do I see my bill of materials? The bomb icon. Oh, nice. What? These have names. Oh, wait. Can we group all the ones that have a description? I kept the pitch consistent, but that's actually not true. What are these? Oh yeah, we need the pulley wheels. Okay, let's just go through. We're just going to go through and do it ourselves, because this bomb thing I don't really like. How do I hide mates?
This video explores how to locate a new mate within assemblies through different methods. By default, after defining a mate, the mate is hidden in the graphics area. The first workflow to find a mate uses the keyboard shortcut J to reveal all mates within the active assembly. Then, you can select the mate you are looking to edit. This workflow shows all mates in the assembly, and it may show several icons.
What if I hit J again? How do I hide this crap?
In the graphics area if you are working with dozens or even hundreds of instances. You can also show and hide all mate connectors by using keyboard shortcut K. Select them.
Please work. Nice. Okay, that's way better. K. Get into CSV. Yeah, I could export the CSV. Step motor, what are you doing? Okay, yeah, sure. Let's export the bomb. At least we get the add column name. Right. See, that's great. All right, that's what I wanted. I wanted name. I don't know why name is not defaulted in there. Oh, wait. Flattened structured? See, that's kind of nice. But we don't really need that. We can flatten it. All right, let's get the CSV. Okay, hold on. I got to do this. This, Amazon. Make sure that it doesn't have my... Okay. All right, so... Okay, so they're $14 each. Okay. Copy link. Okay, so let's just... So wait, first off... Source, tinycnc, paste. Okay. All right. So we have this. So now we're just going to do price. Well, actually, I don't know. I don't really want to do price. Wait, why does it say 2 of each of those? See, that seems wrong, right? Because it's not like there's 4. Wait, hold on. Wait, what did it say? So if I have... I don't know why there's so many repeats in here. You know what? Because yeah, it's kind of unfortunate. All right, this will help me, but this is not going to do that. This is not what we want. So here's what we're going to do. Okay, so that we're just going to write it by hand, kind of. Okay, so it's 2 stepper motors, 4 pulley wheels, and I'm pretty sure I have the link for that. The rail, that's fine. The carriage, the X carriage, that's okay. The 2 limit switches. We'll find the bomb for that. The only reason why I want this CSV right now is really to count how many bolts you need. Oh yeah, let's do, this is not going to be in there, so let's do this time GT2 timing belt. And I need to get all the Amazon links for this ready too. Okay, so we got that. We got the limit switches. This, okay, threaded inserts. Yeah, let's just say, it's interesting because threaded insert, it's not going to have its configuration dumped. So let's just say threaded insert kit. What do we need? We need 2 3.24s and 3 4.5s. I think. I'm trying to think. What are all of the? Oh no, but you need some 6s too. All right, so the only reason I'm doing the bomb really is so they can get an idea of how much it all costs. Okay. Okay, 4. Let's see, 1. Oh, we need the rods too. Yeah, and you need actually 2 sets of rods because you kind of need to cut one of them. Yeah, so we'll have to explain that, document that too. Okay, so then we need 4 M2x8. M3x30. No, wait, where's the M3x30? Oh, wait, is that say 2? Where's the M3x30? Let's find that in the document, in the thing. I wonder if I can find that. If I click on this, where is this thing? Oh yeah, see, this is not supposed to be 30. We need to replace that. All right, so let's I think I should be able to edit. I'm pretty sure that you can. I think you have to do this. So wait, let's just open in a new tab. Wait, that's not what I wanted, bro. What the hell? I don't know what that was about. Okay. So we need to take this guy, replace edit standard content instance to a 20. Much better. Okay, and then this one. What? Okay. Okay, so we need, so I guess we'll have to keep freaking doing this. All right, so we definitely need 2 M3x20. Ugh, it's so annoying, this white theme for some reason is totally broken on my computer because the cursor just gets hidden. It's totally ridiculous. Okay, 2. Is that the only nuts that we use for real? Yeah, where else do we use nuts? I guess we need 2 M3 nuts. And they're specifically thin. We don't need, where does this get used? Wait, did we ever do, I think I forgot something too. Yeah, we forgot this. Okay, so we need to insert. So I'm pretty sure, what is the distance from here to, is it this? Wait, is that true? I feel like that's wrong. Or I mean like, seriously? Oh wait. Oh, so you do. All right, so we need to insert an M3 by 30. So we do need 2 of these. So wait, hold on. Let's do this, and let's select this and this. Okay. Yeah, I was pretty sure I fixed that. And what's the thickness of this to here? That's so we can do 2 10s. All right, so we might as well put 2 10s just to complete this. So okay, so this is good. I'm actually really happy. I'm getting through a lot of the crap. So, okay, wait. So what I want to do is I want to actually export this bomb again. Actually, you know what? We should just go through this thing like this. Oh, wait. Is this going to get updated? Oh my gosh, it has a different pitch. Are you joking? I think I want to just standardize the pitch and not keep track of pitch. Where is this freaking bastard? Oh, but you know what? We don't have an M5 by 30 like that. So what we need to do is we need to go here. Oh, it's so annoying that you have to like go. So first off, we don't want this. So we need to go and we need to adjust this. So we gotta go like this. And this is not. Oh, this is crazy. But if you really wanted to assemble it, it actually is important. That's what's so unfortunate about this whole thing. Okay, wait. Let's just put that in. I'm not gonna change it, but let's just keep that as it is. Can we hide this thing? Okay. Okay, so this one M5. So let's also say bolts are socket head unless otherwise stated. Okay. 1 M5 by 30 hex head. Okay. 4 M3 by 30s. What are the 4? Hex socket. We use 14 of these? I guess we use them all over the place. Okay, wait, where are the 4 here? There's 2 there. And where are the other 2? What? Are these duplicates? And of course, because you're in full, you're not allowed to delete them. That's so weird that I got duplicates. Okay, I don't know. I don't know what's going on. Okay. I like that the bomb updates pretty fast, though. Okay, so where were we? 2 M3 by 30s. I guess we do. Honestly, I'm not convinced that this isn't a duplicate also. Where's that 14 at? So 2 there. 2 there. 4 there. 2, 4, 8. Excuse me. 2, 4, 8, 10. I don't know where it's getting 14 from. There's got to be some weird duplicates. We got 8 there. Oh, you know what? Okay, we got 2 here. Okay. So that's 2 in X. Okay. And there seems to be no problems there. There it is. See, that's what I'm saying. It's for some reason it's so easy to add duplicates. I don't really get that. What is up with that? So let's just go boom, boom, boom. Oh, and of course you got to switch to Y first. Yeah, why not make my life really freaking inefficient? That is so bizarre. I'm going to clean up this town. Okay, that's way closer to correct. Okay, so we got God, it's so cold, bro. Okay. So let's go back to the bomb. Okay, 10 M3 by 10s. That sounds about right. The carriage, that's okay. The printed parts are not listed. That's fine. Let's move the name. Oh, great. You can't move the name column. That's silly. You got great. You got to do this. Move left. Move left. Who designed that? That is ridiculous. Oh, yeah. Okay, linear bearings. LM8UU. I don't know if that's a real... Okay, then you need... I forget. Okay, I guess you need 2 sets of rods. Really only need 3 rods. They came in sets. We gotta go find all the Amazon stuff for this. I can do that off stream though, so that I can go to my real Amazon. Oh, yeah, we got the rod. That's a printed part. It's a threaded insert. I'm not gonna specify all of those. The bolts I'm gonna specify, but that's fine. Hex socket kit. 10 M3 by 8s. That sounds plausible. Let's see. M3 by 8. 4 there. This is so... I need a bigger table. Okay. Yep, that's right. 10 M3 by 8s. Wow, you really don't realize how many fasteners you need. What is this? Oh, yeah. M6 by 12. 4 M6 by 12. Don't we need one? Don't we need more of them? We need to add a So let's go to Z. I'm gonna just put it in Z. I guess the nice thing about using the standard content is at least it plays a little nicer with the bomb. The bill of materials. Bruh. Okay, I got a plan. I'm gonna clean up in the stream. I'm gonna move upstairs. I'm just too tired, bro. The print's gonna be done in 30 minutes, and then we're gonna assemble it upstairs where I can get a heater and it's warm. It's just too cold outside.